We are finishing up the practice test. Remember the sections for this little bugger are 5.3 to 5.6 since we already took the 5.1 and 5.2 test before holiday break. And so far, seems like things are going really well. As I was watching everybody yesterday, you were writing like crazy and getting things down before we even talked about it. So let's get to number 10. This was where we had to stop yesterday, where it says, use the rational root theorem to list all the possibles. Well, I thought we stopped right here. I think the other classes maybe didn't get this far then. Well, it's on the video for them, huh? So we even went through and made all the little fractions? Cool. We're ahead by one. Alrighty. So now, this one says, find all the zeros of the following function, show work for credit. Yeah, you can't just write down because my graphing calculator told me so. You know, we already know that. With this one, we probably want to think about the possibles again and start with the 20 back here. And then the 1 in the front. So what this tells me is if in my little negative 10 to 10 window I don't see the zeros that I need, it's possible I might have to go all the way out to 20 over 1. So I might have to make my window bigger so that I can see everything. Because when I look at this one, I know we don't know how to factor this. This has 5 terms. We don't know how to factor stuff with 5 terms, so this one definitely has to go into the graphing calculator for us to get an idea of where some nice zeros would be. And there's 4 of them, of course, because this is a quartic. But let's put it in the graphing calculator and see if there's some nice ones there. X to the 4th plus 3x to the 3rd plus x squared minus 12x minus 20. We'll try zoom 6, but we only see 2 of them. So then, like I said, we know it could go as far out as 20 and negative 20, so let me just try like negative 25 to 25. Nope, we're only going to get 2 real zeros out of this. So where should we check first in case they were super nice? Second graph. Ooh, 2, 0. That's a nice one. Negative 2, 0. That's another nice one. But yeah, we can do zoom 6 and we could just go back to the graph and count and say, oh, look, that looks like it's going through negative 2 and 2. And then second graph to the table. Negative 2 and 2 seem to be it. Well, we have to find all 4. But this is a start. So remind me, what do we have to do with the negative 2 and the 2 now? What do we do?
Do you need to show all the for the credit thing?
You do. Oh, this thing right here? No, and here's why. Because the problem before this had us giving you credit for writing out all the possibles. So if you forget to write down all the possibles on this one, we're not going to take points off. No, we won't. I know, because usually we grab the graphing calculator right away. Okay, now you said synthetic, right? So, do we have any zeros in this one? Anything missing? Okay, be watching for that on the test. Do your synthetic and make sure we get that 0 in here. Should I start over for positive 2? Starting over from the beginning? 2. Bad plan, right? Just go with 2 from here. So negative 2 worked. Go with 2. Don't start over at the beginning. Remember, we have to work this down so we can find the other 2 zeros. Bless you. Now let's write down what we actually have here. Remainder constant x squared. So right now we're at this point where we have x squared plus 3x plus 5, and we need to know where they equal 0. Ideas on how we could find those. Quadratic formula. Yeah, that's the safe way to go. This one would not be a good completing the square problem anyway because our middle term is a 3, and that's going to create a fraction when we divide it by 2. So instead we'll do a is 1, b is 3, and c is 5, and x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's see what we get. So it'll be negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 1 times 5 all over 2 times 1, which is 2. What's 4 times 1 times 5? 20. What's 9 minus 20? Now we have to figure out what on earth the square root of negative 11 simplifies to. Any perfect squares that go into 11? So what's the best we can do with that one?
Square root of 11i.
That's it. Square root of 11i. So there will be no additional simplifying in this one, because we got that nasty little square root of 11 sitting there that we can't do anything with. So this was 1, 2, and how many zeros does this one count for? 2 of them. That's all 4. We got them. Now if you're saying, but Cedarholm, we didn't do synthetic with these, so does this count? Absolutely it counts. We did algebra. So 2 with synthetic and then 2 with algebra, and we've got all of those zeros taken care of. Next up, the product of 3 consecutive integers is 1,716. Write the polynomial equation in factored form and solve to find the numbers. Verify your answers synthetically. Whew. Anybody remember how to start this? Well, do we know what? Oh, Jack.
A plus 2 times a plus 1 times a.
Makes sense, everybody? A or X makes no difference. Absolutely no difference. I think I'll use an X down here. So we're going to multiply these together. And that has to equal what? Yeah. Because remember, consecutive integers mean one right after the other. So if the first one's X, well, then the next one's X plus 1. And the one after that is X plus 2. It's like the numbers 5, 6, and 7. You know, how do you get from 5 to 6? You add 1. How do you get from 5 to 7? You add 2. So this takes care of write the polynomial in factored form. But we're not done because it says, and solve to find the numbers. So we're going to have to multiply that bugger out. Let's do FOIL on X plus 1 and X plus 2. And then distribute that additional X. What else should we do? Yep, we want a 0 on one side. Subtract that nasty 1,716. Now, it's possible that that might be factorable by grouping. It's highly unlikely, but it's possible. And the reason I say it's highly unlikely is because of this huge number, 1,716 back there. So how could we find the answer if we can't factor it by grouping?
Calculator.
Yes, the calculator. Just like we did in the last problem. We'll punch this in. We'll see. What's that 0 for this one? X to the third plus 3x squared plus 2x minus 1,716. I could graph it, but all I really care about is the table. I want to see where the answer is. So second table, well, it's not 0, 1, 2, 3, or 4. We just keep scrolling. Aha! There's the first one. So what are the other two? And? Well, let's make sure, huh? Let's multiply 11 times 12 times 13 and just be sure. It is. But look what it said to do. Verify your answers synthetically. So didn't we get 3 answers? Which one do we have to verify synthetically? Just the 11. It's the one we saw in the calculator. So we have to verify that 11 is absolutely going to work. 1x to the third, 3x squared, 2x, negative 1,716. So got some obnoxious numbers here to do your synthetic with. So we'll need to know 11 times 14, which some of you know in your noggin, but some don't. Oh, there's a trick to multiplying by 11s. So not quite as easy as 9s, but it's along those lines. So some people can do those very quickly. So that will give us 156, and then 11 times 156. Big shocker. Ta-da! And we'll get all the points for the consecutive integer problem. Woohoo! That's the practice test, everybody. So let me stop the recording. Oh, I should say you've got your little slips for the review on there. And I'm going to give you a candy partner now so that you can get to work on those.